Hi, welcome to Office Hour. This is Mrs. Alidros. Okay, in this video, we're going to be figuring out how to calculate protons, neutrons, and electrons in an atom. And this is the mnemonic that I would use to help you memorize it. So the atomic number is something that it can be found on the periodic table. If your periodic table has these boxes that look like this, the atomic number is up here. So in this case, we have carbon with the atomic number 6. Now, the atomic number is always going to be equal to protons. And this is 100% true all the time. So the mnemonic I'm teaching you guys is APE. So we have atomic number is equal to protons, and that is also equal to electron, but it is only true if the atom is neutral. And when the atom is neutral, for example, these are some examples right here. You can see helium, neon, argon, fluorine, and chlorine. So the overall charge of these atoms is 0, so it's neutral. There is no charge, no positive, no minus on top of these atoms. Okay, so if the atom is neutral, protons will equal electrons. So in this case, if we look at this carbon, and assuming this carbon is neutral, that means since the atomic number is 6, it's also going to have 6 protons, and since it's neutral, it's going to have 6 electrons. Okay, so that's how you use the above mnemonic. And just to show you guys, these are some examples of atoms that are not neutral. So you can see Li+, Na+, NH4+. Anything with a plus or minus is not neutral because they're charged. They have a positive sign on top or negative sign on top. Alright. So for the next one, this mnemonic helps you calculate how many neutrons are in an atom. And before we go over how to use that mnemonic, let's go back to our atom. Okay. So in an earlier video, I said that protons and neutrons, they weigh more than electrons. And you know that because electron is 10 to the negative 28 power. Proton and electron have the same mass, but they have something that's 10 to the negative 24 power. In this case, protons and neutrons are heavier, because when you have a negative exponent, that means you're moving the decimal more to the left, so you're making the number smaller. So protons and neutrons are heavier than electrons by a lot, because you have to think, electron you have to move 4 more decimal places, to the left. So this means that when we're calculating how heavy an atom is, we don't count electrons' weight, because electron is so light compared to the other 2 particles, so we don't care about electrons' weight. Okay, so our mass, when we're calculating the mass of an atom, we only care about protons and neutrons, which is what's inside the nucleus. We don't care about electrons because they weigh so less. Okay? So this means that if I were to calculate the mass of one atom, if I were to calculate the mass of one atom, I just add up protons and neutrons, and that's it. Just protons and neutrons, because electrons are very light. Okay, so knowing that, okay, so if we have a problem that looks like this, And I need to calculate the number of protons. Again, we're going to go back to that ape. And ape says atomic number is equal to the number of protons. So since the atomic number right here is 8, proton is going to be 8. Okay. Next, since this does not have a plus or minus sign here, that means the electron is also going to be 8 because my protons should equal my electrons. Okay. Now in this case, they gave me the atomic mass right here. Usually, when there's a problem that asks you to calculate neutrons, they should give you the mass number. If they don't give you the mass number, you assume it's the number from the periodic table. So in this case, we have our mass of 16. Our mass contains the weight, the mass of protons and neutrons. Okay, but I don't want protons weight in here. So what I'm going to do is I'm going to subtract proton. Okay, I'm going to subtract proton, so minus 8, and that will get me 8, which is 8 neutrons. So I'm trying to get rid of the mass of protons. Okay. And what we just did was the second mnemonic, where we have mass number minus atomic number, which is atomic number is the same as protons, and it's equal to neutrons. So that's what we just did. We did 16 minus 8 protons equals neutrons, because protons and neutrons, they make up the weight of the atom. So that is our mass number. Protons, neutrons, these two together, protons plus neutron should equal 16 right here. And that's how you calculate the number of protons, electrons, and neutrons.